Hi, I'm Eason, and today I'll be presenting my final year project titled AI-based fatigue detection for team-based sports player performance optimization. This project is under the guidance of my supervisor, Associate Professor Mohammad Azam. So re- uh, let's dive into the reason. Let's dive into. Hi, hi, hi. My name is Eason. Hi, my name is Eason. Hi, my name is Eason. Today, I'll be presenting my final year project report. Hi, my name is Eason. Today, I'll be presenting my final year project titled AI-based fatigue detection for team-based sports player performance optimization. This project is under the guidance of my supervisor, Associate Professor Mohammad Azam. So let's dive into what actually inspired us to come up with this idea. Fatigue is a critical factor affecting both athlete safety and team performance in competitive sports. Just imagine that you're a coach for a basketball team. If you are able to understand each of your players' physical state condition, you will have an advantage in making strategic adjustment, reducing injury risk for all your players, and gaining a winning edge in all matches. Through our research, we found out that fatigue management remains an under-addressed factor in sports. Conventionally, coaches and players have relied on subjective evaluations such as personal judgment and gut feeling, which leads to inconsistent decision making that might cost the team the whole game. Another challenges that our project seeks to address is the limitation of existing fatigue detection technology in the sports industry. Currently in the market, all of the fatigue detection technology relies on wearables which might cause discomfort in players during matches. The goal of our project is to create a system that is able to detect and identify players in basketball match footage using the YOLO V8 object detection model, track player movement patterns across video frames using an LSTM model, estimate player fatigue levels by analyzing movement speed and posture variation using a GBM model, and develop an interactive monitoring interface that can visualizes player fatigue levels. So, what is our proposed solution? It is TeamPeak Spot Fatigue Detector. What is it exactly, you might ask? It is a desktop application that uses image processing and various deep learning models to analyze basketball video matches. It is able to track and analyze player movement speed and posture to detect for fatigue indicators. The objective is to provide actionable insight for performance optimization. There are three main intelligent components in our system, which are YOLO V8, LSTM, and GBM. The YOLO V8 detect and track basketball players in match video footage, perform post estimation, and detect key points on the basketball court which is needed to calculate the player speed. Then the LSTM will analyze the temporal changes in the player movement speed and posture over a period of time. And finally, the GBM use features derived from LSTM to estimate and classify player fatigue score based on historical and current performance data. For our AI-based fatigue detection system, it consists of four different modules. The first and video analysis module is responsible for detecting and tracking the players in the video footage, as well as detecting the key points on the basketball court. The second fatigue detection module is the main component of our system, where it will handle the task of movement analysis, posture analysis, and player fatigue indicator. The desktop application interface module is where the user will be interacting with the system by uploading video and viewing the result report. Finally, the cloud service module will handle the heavy computational load of the system by enabling data storage and hosting deep learning model. So here's a simple system architecture diagram of our system. So first, the user will upload a match video footage to our front-end desktop application, where the front end will send a fast API request to the back-end services, which is hosted on a platform called Model. Here we will have our deep learning model, which is trained using Kaggle TeamTrack dataset, which is trained on Google Colab, and the video analysis result will then be sent to the MongoDB Atlas cloud storage where it will be stored and returned back to the front end to be viewed by the user. So let's proceed with our system demo. So our as you can see, we have successfully developed from our demo, we can see that we have developed a system capable of detecting players' fatigue through data-driven assessment and established a solid foundational framework for a scalable solution that can contribute to future advancements in sports analytics. This system also offers commercial opportunities by such as packaging this system as a sport analytics packaging this system as a subscription-based service for sports academics, professional teams, and fitness center to monitor athlete fatigue and optimize performance. Furthermore, we can also integrate the system with existing team management platform to enhance tactical decision with physical condition data. Enhancing tactical decision with physical condition data. That's all for my demo presentation. I hope you like it. Thank you very much.